Hi, my name is Kavina Peters. I am an environmental economics and policy major at UC Berkeley. This summer I was working with the International Rice Research Institute, or IRRI, located in Varanasi, India. This is actually the South Asian cohort of IRRI. The main IRRI is in the Philippines. So this summer I was working on specifically increasing low rice pulse system productivity in Orissa, so focusing on the issues of rice agriculture in that area because Orissa experiences extreme types of abiotic stresses and also has significant issues with inefficient management. It experiences both drought, flood, and actually high soil salinity because of its location near the Bay of Bengal. And in addition, it has very low access to good irrigation, and many of the traditional management practices that are used for rice farming require high labor input, which is not viable with the high rates of rural depopulation in the area. And then finally, there's this issue of leaving the land fallow during the rabi or dry season, which can reduce the amount of nutrients in the soil. So some of the things that I was really interested in discovering were the traditional ways that were used for rice farming, specifically bushing and petal transplanted rice. Both of these systems use a lot of water, and they also use a lot of labor. On the left we have bushing, and on the right we have petal transplanted rice. So what has kind of IRI has been able to test on test fields, and that has worked and been able to increase yields in that area are drill direct seeded rice and mechanical transplanted rice. Both of these do also have the issue that it's very difficult for farmers to attain the technology used in these pictures, and it's difficult and maybe expensive to attain those as well. So my main idea of the project was really to try to figure out, can we create a system, a decision support tool for farmers that allows them to combat the abiotic stresses that are exacerbated by climate change and, of course, the inefficient management systems that they are working under. So potentially we might be able to put in these inputs of asking when the crop was planted, whether there was drought, flood, soil salinity issues, what district, because often in high plateau lands they may not want to plant rice at all, and many of these other issues which may then allow us to estimate what kind of management system they should be using, and of course the yield and the benefit that they might get from changing and switching their reference system for that. So in order to look through this, I decided to look at multiple other decision support systems that were created by IRRI, specifically the Rice Crop Manager, the Nutrient Manager for Rice, the Rice Doctor, Weeds, and WeedSmart. All of these were interesting online resources that are used by extension workers specifically to aid farmers in the rice system. And that was most of the literature that I looked into for my research project. So why this is important is that knowledge-based, site-specific decision-making is the future of agriculture, specifically because agriculture holds all of these low yield issues and unsustainable practices that would need to change in the future for our growing population needs and, of course, climate change as a risk. But in this project, I really loved learning how to create a research project, and gaining that background experience was actually helpful to get a research project that I'm in now, which I'm super grateful for. And I think it'll also help me in the future research, just thinking about how to create a project and how to go about in a research landscape. So I really want to thank my research advisor, Dr. Panir Selvam Paramayan of the IRRI internship, and then of course the director Fräulein Fuller, and my Borlaug-Ruan internship supervisor, Rebecca Picard. Thank you so much.